Guess who is back? My nightmare. 2011 Chrysler 300. This is the one that I changed the cam and you know, both heads, whatever. Now it has a misfire. There's nothing better than doing a misfire today or tonight. You see the engine is pretty shaky right now. Couple codes. We have a P0300 and a misfire, engine oil pressure sensor. It's actually misfire pretty badly right now. And then we have a P0132 O2 sensor, super high voltage bank 1 sensor 1. Let's look at some data. So we're gonna look at the sensors, upstream, downstream, the fuel status. Let's go short term, bank 1 and 2, long, and then bank oxygen sensors. Let's see, bank 1 and 2, 2 1 2 2. Okay. Now, look what we got here. So our fault, we see that we are in the open loop on a bank 1. On the bank 2, we are. What? Bank 2, it looks pretty good, but the bank 1, even though it's in a open loop, for some reason it's taking so much fuel away, 25%. Now looking at the oxygen sensors, I think these are like a lambda. 1.2 on upstream, and downstream on is pretty much peg lean here. So computer is some throttle here. Now the this seems to be just the old-fashioned narrow band sensor. It's kind of messed up on the bank 2, kind of choppy as well. But the on the bank 1 is pretty much actually on a high voltage. Seems like it almost like shorted to power, something like that, because 1.2 volts, that's the maximum that computer would actually show on the data. So we need to check the voltage on the sensor wire by looking at the downstream. You can see the downstream on the bank 1. I mean, it was rich during the acceleration, but it goes down pretty much to zero, and that's because the computer is taking so much fuel away trying to bring this voltage down, this signal down. But what it does, it takes way too much fuel out, and pretty much, you know, this engine is starving for fuel, and we need to figure out why. Of course, there could be actually, well, I'm not sure if it's an open, does it have a bias voltage or not, but this is kind of interesting. So, you know, I don't understand the strategy when they program these computers. I mean, the computers definitely sees a fault, and it's in an open loop, but yet still doing the correction. It's taking so much fuel away needlessly. It should ignore this sensor all the way around, but it doesn't. Interesting. Alright, let's do the checks at the sensor. So on the bank 1, upstream sensor is right there, it has the harness, and I'm on one of the wires. Now when you look at the sensor, you'll see that two white wires, that's your heating circuit. It's a bit two white and two black ones, depends on the sensor. So this one has two white wires on the top. And now the gray one and the black one, so one should be ground, one should be signal. So I'm on the first wire here, and I'm reading 2.5 volts. Let's go back to the other wire. The other one should be my ground. That's interesting. The other wire reads 4.2 volts. Okay. I'm going to unplug the sensor. I want to see the voltage then. I just found the explanation about how this sensor works, and it says the ground circuit is biased with 2.5 volts. Voltage readings in the sensor output is about between 2.5 to 3.5 volts with the sensor connected. And then you got a 4-wire O2 sensor, heated zirconia O2 sensor, heaters. Then you basically have a heating circuit. Those are two white wires. And interesting that it's like a floating ground or something, so it's not the zero, but our output voltage instead of being up to 3.5 volts is like 4.5. But looking at the data, I mean, it seems like old-fashioned O2 sensor from 0 to 1 volt. And so we're gonna check the heating elements. I'm gonna put the current clamp and make sure that we got a good heating circuit, and then I'm gonna unplug the sensor anyway just to see what kind of voltage I'm gonna have on my signal wire. And if that works okay, we're gonna put new sensor in. Got my current clamp over the one of the white wires where my heating element is, and we have a current. So the heating circuit works fine. I got my sensor unplugged, and still at 4.2 volts. Basically, we have an open circuit. This is a bias voltage, and sensor does not work. The heating element is good. The ground is 2.5 volts. That's good. That's where it should be. You pretty much have an open sensor. And now what I can do, I can use my, so I got a piggyback here. I'm going to take this one end of my wire. I can touch it with my finger here. And let's see I can drop in the voltage down. I'm using resistance on my body. And let's look at the, you can see the sensor went down to 0. Finger off, 1.2 volts. Finger on, 0 volts. That's what I was doing. I was pretty much just using my body as a resistance to lower this bias voltage. And we just need a new sensor. This one is not working at all. This is what we have to pay attention. I mean, this is actually a very good way of figure out, if the sensor, upstream sensor, is reporting correct mixture, because we're seeing that our downstream sensor is completely lean. The computer is taking the fuel away. It shouldn't take the fuel away. And by looking at the, let's see, the bank 2. Seems like on the bank 2 this catalytic converter is completely shut. It doesn't have a code for it, but you can see they're actually kind of matching anyway. And but there's the big discrepancy on the bank 1. I mean, this voltage should not fluctuate like this. It should not mirror the upstream sensor. It should be nice steady voltage, maybe around 300-400 millivolts or something like that. Depends on the mixture, but this catalytic converter is completely gone, and I'm not surprised because on the bank 2 that's where we had a massive misfire from a bad cam. And so we're gonna get a new sensor, and they should fix this one. Well, I got a new sensor in. That's Bosch. I'm having a hard time to communicate with this car if I don't start it up. I press the start button twice and still doesn't. So okay, anyhow, let's look at the data now. Let's see if I can maybe clear the codes. We got an oil pressure switch as well. Let's see. know if it's gonna let me do it when the engine running, but there you go. That's okay. Let's see data here. Still misfires. Sorry about this glare. Okay, so the upstream sensor now, it's waking up. You can see it's actually at the low voltage. The problem is right now we're still in the open loop, and we're still taking the fuel away. So what I have to do, I have to clear this memory. Most likely what I'm going to do, I'm going to disconnect the battery. That's the best thing I can do. The problem is, you know, it's an open loop. I was thinking about it last night, and the short term is not doing any fuel correction. Doesn't look like it. However, you know, it still remembered a long term, and it just keep taking the fuel away. Now you're still on the downstream is still low. It's still taking the fuel away, so this it's not moving from zero. I'm going to disconnect the battery, and then we'll go from there. Just started up after like 10 minutes. Still running rough. It's getting better. Slowing down a little bit. Unfortunately, I'm still in long term, you know, -24, and it's even taking more fuel away for some reason now. Let's see the codes. It should clear the codes at least. Huh. Well, that's weird. Now I'm in a you know, Chrysler specific. Let's go codes only. Pressure circuit, so pretty much the same. Okay. Now, let's see if I can clear the codes. Okay, now let's shut it off. See if I still can communicate with it. Oh, come on. It says ignition on. I need a memory reset. That's what I need to do. But I can't communicate with this with the engine off. I don't know what. Ignition or accessory on. Okay, so that should. Alright, how about now? That could be promising. Let's do memory reset real quick. Okay. So all adaptive memory, let's do that. Okay, cool. Okay, so I guess, alright, let's go ahead and clear the codes. Finally, let's look at the data now. So I think this, the way this Chrysler sensor works, they go from 2.5 to 3.5 volts instead of like 0 to 1, but if you're in a generic, it kind of looks at the, seems like they're just narrow band sensors, or I don't know, I'm not exactly sure. Alright, so let's just start it out. Let's just wait. Let's see now. I need a sensor level. I need a 101 voltage. Oh, so you can have an option from 0 to 1. Okay. Okay, that's okay. Then I'm gonna volts here. 102. And then where is the number 2? 2, 1. Where's 2, 2? That's why I like the OBD generic for this stuff. Long term 101. Long term 201. Okay. I'm sorry about this stupid gym. Just what the heck, just see what happens here. I don't know. So the long term, they're both on 0. And 1 and 1, it's working. 1 and 2, it's working. Nice. Phew, stinks. Finally. Woo, smooth. I'm gonna go to OBD direct because I can. All right. Here is this snap-on virus, set some kind of virus and just froze the screen, so I had to reset everything. Anyhow, we can see that we're on both in closed loop now. Engine runs 10 times better. The short term on bank 1 and long term, so the long term is 0. The short is -3, -5. The long short on the bank 2, which was okay anyway, so that's perfect, below 10. The sensors are still kind of on the. I don't like the way this sensor runs, but the computer likes it, so this one looks much better on bank 2. That looks pretty crappy actually. I'm going to take it for a test drive and see if the sensor is going to wake up. You can see the downstream is working as well. I don't like this pegged ridge. Computer's in the short term is taking fuel away. And nowadays you don't even know what kind of sensors you're gonna get. Come on, do something. Now we're taking fuel away again, trying to lower this. Ah, crap. Now you should start adding fuel because you're peg lean now. Short term should react. You should start adding fuel. I don't understand why this sensor is not working the way it should. Ah, God. There you go. Let's take it for a test drive, see maybe the fuel trim is still messed up and it's trying to level itself up, and the sensor definitely, this is not good at all. Oh, this thing runs great now. It really at 60 miles an hour, accelerate just fine. The oxygen sensor finally woke up. You can see there's both are working. They're kind of having crappy signal on it, but as long as the computer is happy, I'm happy. But definitely it's just needed more time to be driven to learn the fuel trims and all that, but you know, it's working. Sorry. Definitely had a problem on the oxygen sensor. It was peg rich, and computer was taking the fuel away needlessly, and that's it. Now, when I got this car, I didn't film the first part. When I got the car, of course I was concerned. For you guys who follow me on this channel, you guys know that I had did a lot of work on this engine, and I changed the cam and push rods and all kinds of stuff. It was a pretty messy job. And so first thing what I did a clear flood mode. I could see, of course, the engine is misfiring. I did a clear flood mode, and I could hear the consistent cranking. So I told the owner right away. I said, "No, don't worry about this. It's not the compression. It's not the mechanical issue on the engine. Something else is going on." Now the next thing I did, I used my picoscope and I just to confirm that I have a good compression. I like the option, the Pico, that you can actually do a quick compression test by simply putting your test leads on the battery, and the Pico actually does a look at the voltage drop across the battery as you're cranking the engine, analyze it, and it gives you like bars, and of course you choose, you know, is it a 4, 6 or 8 cylinder engine, and it will give you a quick idea if you have a compression problem. Now that software, the program, it's not going to tell you what cylinder is misfiring. It tells that a cylinder is misfiring, which is enough for you to give the funnel to know what to do next. So that was consistent. My lowest, it was like 95 or something like that. So so anyhow, that was fine. I was happy with that. So the next step was actually, I again went to my ignition. Sorry I didn't miss the film that, but I used my paddle probe. I really had a hard time to find a misfiring cylinder, so I took a paddle and went to one cylinder to another. I could not see any misfiring cylinders that would be related to ignition. Now, why I do that first before I even touch the scan tool? Because 60 to 70% of the time the misfire is ignition related, and these coils were very easily accessible, and I could take my paddle, just go from one to another coil, and see if I can spot something that's not right, and didn't really see anything. Said as well, this is not ignition problem. Let's go ahead and look at the data on a scan tool, and I've seen that my fuel trim is completely messed up, and the sensor, it's not you know, working right. But one of the things that I want to emphasize, as I said before, you need to really pay attention to downstream O2 sensor. The downstream O2 sensor is basically like your gas analyzer. It'll tell you if what mixture is actually having, and of course, if downstream O2 sensor is pegged rich or pegged lean, you want to make sure that sensor is actually not lying to you. You can, if it's pegged rich, you can simply pull the hose and make a vacuum leak, and if it drops down lean, then you know you can rely on that sensor. Now if it's peg lean, whereas I did this time, I just revved the engine up a little bit and went rich, or you can add propane to see. So basically what you want to do, you want to make sure that your downstream sensor is working, that you can actually rely on that. Now once you determine that your down sensor is fine, then you're going to compare to the upstream sensor, and now we're going to look at your fuel trim. If your downstream sensor is lean and upstream is rich, then your fuel trim is going to be negative. Computer is going to take fuel away, trying to drop that, you know, the voltage down on the upstream sensor needlessly, and the vice versa. So, you know, so anyhow, that's pretty quick way of determine your sensor. Now once you find that, then you need to check your wiring. The first, what I like to do, simply using as you guys can see, using an M clamp on your Bosch sensor. When you look at the sensor wiring, 2 white wires or 2 black wires, that's going to be your heating element, your heating circuit. You put your M clamp over either of those wires, black or white, and you're going to measure current. If the current is there, quick and easy test, it should be around anywhere from 1 amp to like a half an amp, because the computer is actually varies the voltage, depends on the temperature on the sensor. And so once you figure out, okay, my heating circuit is okay, let's go ahead and check the ground and the signal wire, which was interesting on this. I was a little confused that the ground side is actually bias voltage 2.5 volts, which I didn't know that, which is, again, it's just good to have a snap-on tool that you can actually, or any other data, reliable data, that you can actually check it to give you good information what to look for. Now if you get confused, if you don't know exactly what you should have, go to another sensor, go to the bank 2, or you know, whichever bank is okay, and check the voltage on that sensor. And if you have the same, like 2.5 volts on the ground wire, that's normal. And the last, we had a confirm our signal wire, and we could see we had a bias voltage at around 0.4 volts, and pretty much you're done. Now I actually did a test that I actually dropped the voltage down. It's kind of like, you know, you want to make sure you're not shorted to power, but if you're shorted to power, the voltage, actually no, I'm sorry, that was a 4.5 volts, and so you want to make sure you're not shorted to power, but at that time you're going to have a higher voltage than 4.5. But anyhow, I easily dropped that voltage down by touching my. I used my body as resistance. I touched the signal wire, and then I touched with my body. I touched the ground of the car, and I was able to lower the voltage down. It tells me that's a bias voltage, very, very high resistance in that. That tells me that's the bias voltage, and that everything's fine. The next step is put the sensor in, and sure enough, it fixed the problem. Car runs great. And all right, another Misfire case study. It's not a ignition. That's good. All right, guys, that's it. This one is fixed. I'm glad it's not mechanical this would be really a disaster. And that's it. Off I go to the next one. Thank you, guys. Have a good one. Bye bye.